The following is the video solution from JSDT Solutions. Question 2 says, during a netball tournament, there are several stalls selling food and refreshments. In a period of 10 minutes, at 6 stalls, the following was observed. Okay, so they list the stall numbers, and we can see that in the first stall, there were 10 customers, and the amount of money spent was 163 Rand. And 7 and 138 and so on. And they have already put the data in a scatter plot. So from the scatter plot, we can see a general increase, okay, in this trend. So this means that more customers at a stall would typically result in more money being spent at that respective stall. Okay, so the first question, 2.1, is to determine the equation of the least squares regression line of the data. So let's take our information from here and let's just put it down and record it. Okay, so we're just going to go from, you can put your calculator back on comp, and then from there go to stat. Then instead of going for 1 VAR, we're going to go for the option that says A plus BX. So that will be the 2 variable data set that we have. And they've already put this down in the scatter plot, so you can see that the X values are the number of customers and the Y values are the amount spent. So let's go ahead and put that down. That's going to be 10 and 163, but you first put down the X values, okay, and then the Y values. Okay, so we can put that in. And then once your data is in, we're going to press AC, Shift, and 1. Now we are looking for the equation of the least squares regression line. Now that equation looks like this. Y equals A plus BX. And so we just have to find the value of A and the value of B. So on your calculator, you're going to go for option 5, which says regression. So I'm going to have to just go here for regression. And then we can see the value of A, B, and even R. So let's go ahead and check out what A is first. So A is equal to 12 point. Now that's going to round up, okay, and then eventually add a 1 to that 5. So 12.6 is what we have there, but we'll just leave it at 2 decimal places. So 60. And then we need to find the value of B. So again, you're going to press Shift 1 and then make sure that you go for regression, and then B is equal to 17 point. That 9 is going to round that 2 up to a 3. So it's going to be 17.33. Okay, so the equation of our least squares regression line is therefore Y equals 12.60 plus 17.33x. And that is our answer. Question 2.2 says, predict the amount of money spent by 11 customers. So the customers, that is specifically the X values. So we already got the equation of the least squares regression line, and we can just take that, and in place of X, since X is the customers, we can substitute 11. So this is Y equals and all of that, and then times 11, and let's find out what we get here. Okay, and we can see that the amount that would be spent would be about 203 Rand and 23 cents. Okay, so that is our answer. Moving on to the next question. Question 2.3 says, determine the correlation coefficient of the data. So on our calculator, you can just remove all of that. You can just press AC, Shift, and 1. So Shift 1, and then again go to regression. Then you will see that the third option would be the correlation coefficient R. So we'll just tell them that R is simply equal to 0.9, and that's going to round up to a 5, so 9.5. And that is our answer, 0.95. Question 2.4 says, the organizers of the event think that there is a very weak positive correlation between the number of customers and the amount of money received at stalls. Motivate whether you agree or not. Okay, so from the correlation, you can see, yes, it's positive, but it's not very weak. It is very strong. So we can tell them no, and then tell them that there is a very strong positive correlation between the number of customers and the amount of money received at the stalls. Okay, so that is it for this question. Question 2.5 says, at another stall, 6 customers spent a total of 195. Okay, 195 Rand. If this point is included in the data, will the gradient of the least squares regression line increase or decrease? Motivate your answer without any further calculations. Okay, so we're looking at 6 customers spending this amount. Let's look at what that looks like in our scatter plot. So 195 is around here, right? So just above there. And you can see what the data set was doing before. Now, if at another store, 6 customers spend an amount that is around here, you see how that does not follow the general trend of this line. If we had to draw the least squares regression line, it may be something like this, right? Now, this point is away from it. If you start adding points that are away from that line, it messes with the consistency that we would have had, the correlation. So with the gradient as well, it's going to decrease that gradient because now you're adding more points here. So this line will not look the same anymore if you redraw it. This line will always follow that general trend, as in where most of the data points are. So because you're adding more points down here, it's going to cause it to decrease. So it's going to cause it to decrease, and it's especially because we're adding a point that is far, or it's not really because it's far, it's because of where it is. We're adding a point that is below that general trend, that line of best fit. Okay, so we'll tell them that it's going to cause the gradient of that line to decrease because we are adding a point that is below that regression line. Okay, so that is our answer. The gradient will decrease, and this is because a point that lies below the regression line has been added. Okay, and that is it for question 2.